Isn't this Mario game so much fun?
So fun, I love it. I don't feel too good. I think I'm gonna go home, actually.
Alright, I'll be here waiting.
Alright.
Alright, you lousy Goombas. We need to attack the castle's first line of defense.
What's that?
Well, it's the physical barrier. In this case, it's the castle's walls. Prepare to attack.
Oh no! Our castle is under attack. Everyone shut the doors and brace for impact.
The first line of defense of the human body consists of physical barriers. This includes the skin, eyelashes, tears, stomach acid, and mucus. The skin has chemical defenses in the form of acid secretions, which prevent the growth of microbes. Microbes and foreign debris also get trapped in a layer of mucus, and then are filtered out by hair-like structure called cilia. Corrosive acids in stomach destroy most of the invading microbes carried into our bodies from food.
Go, go, go!
That protective barrier is stopping us from penetrating the castle. What should we do?
I got this, guys. Oh! Oh!
One eternity later.
I did it! I did.
What happened to
I
him?
thought it was only a minute.
What was that? He had a family.
That was Lysozyme. Lysozyme destroys Goombas. We need to charge through no matter the costs. Some of you will live, and some will die. It's a sacrifice we have to make.
Mamma mia! They are broken through the castle walls. Our first line of defense is gone. They've entered the building. Yoshi, prepare the second line of defense. The second line of defense, also known as the non-specific defense, consists of three main categories: macrophages, inflammatory response, and the complement system. There are three types of white blood cells in this system: monocytes, neutrophils, which are both baby Yoshis, and macrophages, which are green Yoshis. Each of them kill bacteria through the process of phagocytosis. Phagocytosis is a type of endocytosis in which the white blood cells ingest invading microbes. Macrophages, for example, utilize phagocytosis by engulfing foreign particles and then leaving them behind as harmless waste. When a foreign particle breaks into the skin from an injury, monocytes, which are special leukocytes, migrate from the blood into the tissues. They then develop into macrophages. On the other hand, neutrophils are attracted to chemical signals given off from cells that have been damaged by microbes. The neutrophils then squeeze out of the capillaries and move to the infected tissue. This process is known as chemotaxis. The neutrophil engulfs the microbe and release lysosomal enzymes which digest both the microbe and leukocyte. The remaining fragments are known as pus. When pathogens arrive, basophils, which are white blood cells, release histamine, which causes the blood vessels to swell. This initiates the inflammatory response, which increases white blood cell count and the body temperature. It also causes redness, heat, pain, and swelling. When we have a cold or flu, neutrophils or macrophages digest invaders, releasing chemicals that increase the body temperature above 40 degrees Celsius. There is also a complement system which consists of non-specific defense proteins present in our blood activated from antigens of invading microbes. They can do one of three things. They can bind to an invader, preventing it from multiplying. They can puncture holes into the membrane of the microbe, which kills it. Or they can bind to a microbe, causing agglutination, which attracts macrophages to do their job.
The third line of defense comes into play when the first two defenses are unsuccessful. It is known as the specific defense, as well as the cell-mediated immunity. It involves lymphocytes, which are white blood cells, and two main types: B cells, which mature in the bone marrow, and T cells, which mature in the thymus. Once certain large pathogens are eaten using a lot of effort, The helper T cells, cells with receptor sites that recognize antigens of the pathogens, being Luigi in our case, hop onto Yoshi, our macrophage. He will latch on to his antigens, being his saddle and spines, and begin to signal the B cells, or in our case the toads, to multiply and begin production of the antibodies. The signal is also sent to other T cells as well. The message is sent via lymphokine, in our case mushrooms, which toads love. They will begin creating the antibodies, being the ice flower, which will begin to clump up and slow down the pathogens. Then the macrophage eats the pathogens. The star of the show, Fire Mario, arrives as a killer T cell armed to kill any pathogens that have infected any normal functioning cells. Mario acts as the suppressor T cell, which slows down the immune response before finally turning it off once the pathogen is dead. This power-up represents the antibodies, as they help defeat most foreign particles as they slow them down and are able to be eaten by the macrophage. The memory of the antigens and antibodies is stored within the memory B cells and T cells in case the pesky Koopas need another lesson. The organism now has immunity to this pathogen, which will last several years.
It's too late, Bowser. You've been defeated.
You've killed all my men, but not me.
3 hours later.
Can you move it along? I'm all out of time cards.
I feel so much better now. Somebody's the best doctor ever. Oh no! How long have I been gone?
30 years!
Oh my mushrooms!
I'm almost out of batteries! Oh no!
Did you die?
Just a prank, bro.